Hey, getting into 20-4. That is a force on an electric charge moving in a magnetic field. So if a current-carrying conductor creates a magnetic field, and that's because of moving charge, why is the charge limited, I guess? Why is a magnetic field limited just to moving charge in a conductor? What if the charge is moving without a conductor? What if we're able to project or move or shoot a charge through a magnetic field, and what would happen? There's actually a lot of practical uses for that. One is called a mass spectrometer. I believe I posted a series of Bozeman videos about magnetism and induced EMF. And I'm going to be honest, go to the mass spectrometer one. It's pretty cool. And I think it'll be valuable because it's referenced in an AP test every once in a while. So I don't want you to miss out on that. So anyways, we've got a moving charge. And why don't we just have a charge? When they talk about a moving charge and we start dealing with, the right-hand rule and such, always deals with a positive charge. Conventional current is based on moving positive charges, which doesn't occur, but that's what they went with. And again, our positive test charge is moving. So it's moving through this field, and it's going to experience a force in that magnetic field. And the question is, which direction is that force? When we do the right-hand rule, right, the direction of the current and the direction of the force, if my thumb were flexible enough, right, would be perpendicular to each other. So I've got a velocity or a speed and a force that's perpendicular to it, which is going to create circular motion, okay, and we'll connect those two together. So if I have this charge moving, right, into the field, once it enters that field, okay, which way is it going to get the force? So my right-hand rule, my field is into the page, the x's say into the page. My direction of my conventional current, my positive charge is at the field, so my force is to the left, and I'm going to get curved motion while it's in the field, right? And then it'll go off straight once it's exited it, okay? So first of all, what is the force? Let's get that force, and then we'll connect it with centripetal motion. That force has to do, right? What's going to impact? Well, the amount of charge is going to impact it as far as that force. The speed at which it travels, and that's current, like how many charge passes through a point in time, right? Or over a period of time, how much charge. That's the speed, or the current is setting that. So why not the speed of the charge? And then the strength of the magnetic field. Now, if this charge, instead of parallel to this plane, were to come out of the plane and kind of come out of the page, right, at an angle, that would minimize the force, and it would have that sine theta component, because right now my direction of my charge is perpendicular to the field, so 90 degrees is maximized, okay? So as far as finding a radius, how do we find that radius of curvature, right? To be able to predict where it's going to hit, maybe on the other side. That's kind of what a mass spectrometer does. This force becomes the centripetal force, which is the mass of the particle, v squared over r. So if this is our centripetal force, I've got my q v b, and we're just going to assume maximum is equal to mv squared over r. Okay, mv squared over r. This b goes away as far as v squared, as far as canceling, right? So I've got my radius is related to my charge, my magnetic field strength, the mass of the particle, and also the speed of the particle. Now, we just put this together to start making relationships, and we can make kind of that proportional reasoning. If I were to solve for r, right, that'd be mv divided by q and b. So greater the mass, greater the radius. Greater the speed, greater the radius. Greater the charge, smaller the radius. Greater the magnetic field, smaller the radius. So hopefully by now we're getting to this denominator or numerator, right, relationship, direct relationship, denominator inverse relationship. Okay? So to me that summarizes 24. I'm going to close that video. 25 and 26 are related, so I'm going to just treat those separate. Hope this is helping.